Today's case study video is 3-cylinder petrol engine with eddy current dynamometer. This case study is, suppose if the engine is fault means what will be happen. That is the case study.
So what are the components?
You know in the engine components, what are the available in the engines? The same components also in this engine also. Because it is a 3-cylinder petrol engine, the number of cylinders is 3. So petrol engine definitely carburetors will be applicable. So the main component is carburetor. Inside the piston engine cylinder consists of the crankshaft, connecting rod and the camshaft and all the other components also. Spark plug is the important component in the petrol engine. If you go to the diesel engine, instead of spark plug, there is a fuel injector engine.
So what is the working principle?
Working principle is, this is the four-stroke engine. So you know all the remaining 4 strokes: suction, compression, combustion and exhaust. These 4 strokes will be repeated in the here also. Whatever remains in the working principle, the same thing will be in here. So the same working principle also on the auto. What are the auto cycle? You know the auto cycle. Auto cycle has been 4 strokes. The same thing also happens because it is a petrol engine. In diesel engine, instead of auto cycle, the diesel cycle will be auto.
How is the reading?
For reading, this is the engine test setup is available. It is connected with the electric current. So if you switch on the equipment, what is happening in the all this procedure, how much power will be developed and indicated power and the other power, all will be calculated in this engine test. In this, when we are taking the reading, what will happen? The engine connecting crankshaft is connected with the eddy current dynamometer. So the eddy current dynamometer is used for the loading purpose. If we apply gradual load, what will happen? The fuel consumption will be more. Whenever we are increasing the load, the fuel consumption will be more. Suppose 10 kg load is applying, the fuel consumption will be somewhat. If it is 20 kg means the fuel consumption will be more. Like that, it will be increased.
Sir, from which car it is taken and what is the CC of this?
Here, the CC is not mentioned. In this diagram, they mentioned everything, torque, stroke, bore, everything is they mentioned. For calculating CC purpose, we can use the formula pi d square by 4. If we use the bore diameter 66.5 mm means, if we calculate the 66.5 into d square divided by 4 into 3 means, it will get the final CC. That's why they are giving the Taylor formula. Using that formula, we can calculate the CC of the engine. The main advantage of this is, in the olden days, the petrol engines are calculated by the eddy current dynamometer. Nowadays, this entire setup will be dismantled and arranged in a new item, and instead of the eddy current dynamometer, new loading dynamometer is available. Using the dynamometer, we can calculate the reading easily. Or that only the engine test.
Sir, what's the name of this?
This is the engine, just the electronic digital engine test. Because here there is no linear motion will be available, only the digital information will be available. If you switch on the current, how much power will be developed, how much fuel will be consumed, everything will be displayed in the digital meter. Okay. This is the setup.
So what is the difference between petrol and diesel?
Petrol and diesel means petrol engine means mainly 2 components. One is carburetor, another one is spark plug. In diesel engine, these 2 components will not be available. Instead of that, fuel injector and fuel injection pump, these 2 components will be added in the diesel. That is the main difference between petrol and diesel. Here, the petrol engine, everything is there. It is starting key is they are available. We switch on the engine initially, the crank will be rotated and the reading will be taken in the sequence manner according to the speed load condition. If we increase the speed